So this is Introduction to Computer Graphics, actually our second lecture. We do half of it online, and today we're going for an introduction to p5js. So just a little motivation why we are doing this. A classical Introduction to Computer Graphics lecture would go into math, would make you do polygons and edge lists and vertex and node lists and UV textures. But we're doing it in the context of game engineering. We're doing the game engineering lecture in context of game studies and engineering, which is an interdisciplinary program. And we're using p5js to get kind of a mid-level framework. So it's not like WebGL, and it's also not like Godot or Unity. So somewhere in between to get some hands-on and understand better what computer graphics mean. Okay, and for today, it's very important to get our hands dirty with programming, and that's what I'm actually here for. So why p5js? p5js is a web-based version of processing, and processing was released in 2001. So the idea was to let artists and developers just use a little tool that wraps most of the complexity from Java, and you could do visual art and prototyping. So there's also a high-level API for OpenGL, so real-time rendering is possible. It's quite easy to install and use compared to Java or what Java was at that time, and it's an all-in-one editor and runtime, which has its pros, so you don't download anything else, but it also has its cons, like, well, yes, the editor is not the best, especially not for Java. Yeah, but it was adopted a lot, and I adopted it actually for this lecture, but the problem was that it's clunky, and Java as such is rather outdated. I'm sorry for that. Shout out to the cloud. Sorry for telling that Java is outdated, but I was a professional Java developer for a very long time, and I didn't touch it for years now. So JavaScript is also not a good choice for a programming language, of course, but it's something that can run on any computer without extra installing stuff. So that's the point. Okay, just organizational thing. You can basically use the chat to ask questions in between. As far as I see them, I'll answer them immediately. Yeah, maybe those things you shouldn't put on the chat because you would give away your name, and this is stored on Twitch and on the internet. But yes, I'll check my emails, of course, and I'm very positive that anybody who comes with the second lecture can just join the course. So I hope that answers your question. Great. So use the chat and put in your questions. You can do it anonymously, so that would be the main driving force behind it. If you don't want to go to Twitch because you don't want to have a digital footprint there, record it and put it up for download on the university's internal servers or for convenience streaming on YouTube. Okay, so let's dive into a little bit of processing. So I put up screenshots. I didn't install it on my computer, which yeah, was kind of a hassle yesterday to get the streaming setup running because I changed computers since I streamed last time. So also there is no processing on it. Processing was based on Java 1.7, for instance, for processing 4. I'm sure there's some evolution in there, but the whole idea was that you have this editor, which is this hand up here, and this editor has a setup method and the draw method. And if you recall the game loop, then the draw method would be your game loop. It's called for each frame, and the setup method is run before that. So what you need is to give the size of the window you want to paint in, and then do some painting. For instance, draw a circle where your mouse is. That would be the example right here. p5js, on the other hand, is processing implemented in JavaScript. A lot has been ported. Some things work well, others don't. It's a very fluid community. So last year they released the first version of p5js 2.0. There's still support for the 1.x versions. I'm still using them. There are a few new features, there are a lot of bug fixes, but they were communicated back. So all in all, I have no suggestion what you should use. The only thing you should do is reference the right version or put it in with your exercises. So just to give you a quick look on that, I've prepared something. So this is implemented with p5js. So that is the editor we will use. Up here you can say what you want to use as a version, for instance 1.4, which was at the time when I actually started writing that for advanced topics in computer graphics. And you can do a whole lot of stuff in there. And this is the code for a parallax scrolling demo based on polynoise. So if you want to know more about that, advanced topics in computer graphics is the course to go, but I just wanted to show you that's basically what you can do with it. So you can paint colors in there, you can use different functions that are built into p5js, like for instance noise. Where is it? Where's my noise? Here's noise, so that's the Perlin noise, you don't have to program it yourself, and so on and so on. So that's the benefit of p5js. And yeah, with that we'll basically go to the basics. So close this one. The benefits of p5js are it works in your browser. It integrates into web pages, so you can program stuff in p5js and then just integrate it in your website for your portfolio or put it up on itch.io if you make a game or a game-like application. Then JavaScript is often easier to code, especially in times of large language models, because JavaScript is, yeah, actually a language that they know very well, those LLMs, and it's open source, so it's here to stay. So even if GitHub is closed, even if the community leaves this very much this fork of p5js, it will not go away. The drawbacks, all this 3D stuff is mapped to WebGL. Yes, I will not go there. It's a drawback because the world has moved on. WebGL didn't too much. Creating a video is more complicated. I have a fix for that actually. I'll show you that today. And it has no types, which means that a variable can hold any type of value, be it a string, dictionary, array, whatever. And it doesn't matter, it just works, but it might not work as intended. So what I wanted to do now is to take a look with you at, to take a look with you on your knowledge of JavaScript. Please open your computers. They are obviously open because you're watching Twitch, but you can join it on slido.com. It says there are 21 people visiting the stream, and we could live see what is the output of the following code. Let A be 10, let B be 5, and then console.log A plus B, and what would be the output of the code? Why would I show you that? Because I have a lot of people who say they really know JavaScript very well, and then other people don't know it. And those people who don't know JavaScript can just infer the code from the first example, and those people who know JavaScript by heart maybe guess the function of the last one. So yeah. Okay, so 7 people answered already. That is very good. 9 people answered. There's a lot of agreement. 11 people, yes, that looks good. That looks good. We're more than half of the viewers have actually answered, and I think you're right. Because what does it do? It creates variables A, so a box with label A, which has a 10 inside, a box with a label B with a 5 inside, and then you just mix the content of the boxes with the plus modifier or the plus operator, which then makes it 10 plus 5, which would be 15. Let's see if that is Show correct answer. Yes. Awesome. The next one would be, what does this code return? Const colors is, in square brackets, red, blue, colors.push, green, and console.log colors.length. Okay, I'll give you some time here. I heard something at my door. I'll just go there and close it. And I'm back. Yeah, there's less agreement here. I like it. Less agreement means not only that we can discuss more or we have a conflict, but that we have the opportunity to learn. That is great. As I said, we're anonymous here. That's totally intended, so you can give the wrong answer. Please do not attach yourself to the majority of people. Although, in this case, the majority of people seems to be right. So what does it do? We have another type of variable, which is actually not variable, but it's constant, so it's called const. And const colors is an array. The array itself has two values, red and blue, and the array is modified with pushing green, and then you put out something on the console, so that generates the output, and that's the length of the array. So 3, yeah, you add something, and then it's 3. Okay, so there's more complex things going on. There's an array and there's a const, but 3 is the right answer. Yes, and this is from novice to intermediate to expert. What is the output of this snippet? Console.log type of NaN and console.log dot 1 plus dot 2 is 3 equal signs dot 3. And what is the right answer? In this case, it's a very bad example. So there are a few things in there that would actually, I would just say, I don't know, I have to look it up. So of course you can look it up, but that's basically the edge of my knowledge. When I looked it up, it's, yeah, I understand why, so that's great. And I'll give you the solution here. So it's number and false, because actually not a number is a number. It's a special number. It's the number of not being a number. Adding two floating point numbers and then getting a result and then comparing it to another floating point number, that's something that you don't do anyway in computing, because comparing floating point numbers is always a dead end. What you do is you see how much the difference of two floating point numbers is moving away from 0 in some small delta, and if the delta is small enough, you can assume that they're similar to equal. So this is, yeah, and then the 3 equal signs, they also have a special meaning, and that's what I cannot explain right now, right here. I would have to look it up. But that's okay. Nobody is expected to be an expert here. And this is the one I wanted to show you as the true mastery of JavaScript. No, it's not. But in here, we already have a lambda function. Oh, at least that's what it's called in Java. As I said, I'm with the Java people, or have grown with the Java people. So, and it's already object-oriented programming in a way. And I hope you had enough time to read it. So I'll show the results here. What is the output of the code in the image? A. Okay. So input is V, there's the whole function. The output is A, E, M, or a square bracket. I'll go back again to the image that you can still look a little bit on it. So, and I'll explain a little bit about that. So this cipher object-like structure, and I'm actually missing the terms here. As I said, the last question was already borderline my level, a little bit over that. But in here you have basically, if you consider it being an object, it would have two members. One is shift, a number of 5, and the other one is in code, it's a function, and the function returns something that uses replace regec thing, where it replaces letters with, and that's funny enough, you create a string from a character code, so you need to know your SC code, and shifts it a little bit and modulates it, or makes the modular operator put it back again into the A to C range. This is also called the CISA shift. And the actual question, if you understand what the source code does, is what is the letter that is 5 letters away from V? So that is the actual question, and the actual answer is A is the letter that is 5 letters away from V, because you're with the module operator, you skip to the beginning once again. So it's V, W, X, Y, C, and then you start the beginning, which is A. Okay. So that was just a short thingy on the different knowledge levels on JavaScript. I hope I didn't spook you with that. You don't need to be at that knowledge level, absolutely not. But if you want to dive deep into that, you can actually use all the online resources you have. JavaScript is extremely well documented, and you can take courses. You can partner up with an AI and code with them and let them explain to you what they're doing, and so on and so on. So that's actually the cool part. Yeah, let's stop this one. Go away, come here. And now let's go into a little bit of JavaScript really fast. So what is JavaScript? It's actually a programming language. Yeah, well, some people say it's not, but yes, it is, because you can make programs. It's interpreted, which is totally not 100% right, because the interpreters are more complex than just interpretation, line-by-line interpretation. But compared to sending over a compiled file, which you cannot open and read, JavaScript, if you send a JavaScript file somewhere, then some other people can run it, but also open it and read it, because the source code is sent over there. The source code is not translated into machine code, so that's the interpretation stuff. It has a C-style syntax, so some languages have different styles, but this is a C-style syntax or Java-style syntax, also because Java is a C-style syntax. What else is in there? Swift, for instance, Objective-C, TypeScript, which is mainly JavaScript, but with types, and yeah, Java, I already said that. Wait, C#, I'm missing C#, Unity. It has functions, it is single-threaded, it's object-oriented and prototype-based. Yeah, object-oriented, you've seen what I mean. Basically, you can make creative and great data structures which match something together, so you can create contact objects which then link to telephone number objects, and so on and so on. All these boring examples you have in an object-oriented programming lecture. Downside is single threading. So as you might know, many computers now have multiple processors, and JavaScript can, out of the box, only utilize one. I mean, you can do work around that a little bit, but this heavily depends on the interpreter or the JavaScript engine you're using. In the web, you can use, for instance, workers. And while this is a cool idea, if you install a worker, then it's really hard to get rid of that again. So then you have to deep dive into Chrome. That's kind of weird. Okay, if you learn JavaScript and want to use it for your own purposes on your own computer, you can use Node.js. For instance, that's just one of them, which wraps the Chrome V8 engine in a local interpreter, and then you can run programs on your computer and not only in the web browser. So yes, originally it runs in the browser. So Chrome OS, Electron, Progressive Web Apps, these are all things that work together. So you know, Chrome, most likely Chromium, the base engine includes the V8 engine. I'm not sure if Firefox, maybe the chat knows, if Firefox then switched over to the V8 engine. And I'm not sure Safari and Chromium had the same code base at some time, if they still have their own JavaScript engine or if they also switched over to V8. Yeah, it's a huge piece of software. Chrome OS is something that Google came out with, and it's mostly everything is running in Chrome. So then, of course, JavaScript, TypeScript, all those web-based languages have a high priority. And Electron, for instance, would just create an app based on Chrome with your JavaScript running inside there. And progressive web apps are basically websites that tell the browser, hey, I can also be installed as an app. And then you get an icon, put it on your phone, and you can run it on your phone just like an app, like a lightweight app. For desktop and servers, you use Node.js, and actually this has a relevant share of web applications because Node.js is often used for web programming. It can spin up really fast servers, and so it's really convenient. A lot of libraries, you heard about it. NPM would be the package manager about that. Packages that are put into the NPM package manager can be run from the command line with npx and so on and so on. So a lot of fun stuff. You can look into it if you want to. But we'll just go into JavaScript as the language. What we need is, of course, primitive values. So we can have numbers, for instance, integers. 125 would be one, or 42 would be another one. Or you can have floating point numbers. So 14.24586 or 3.1415, something like that. Those would be floating point numbers. What you always need in computing languages is Boolean values. So they only have two ways to go, either true or false, and that's actually the keywords you use in JavaScript. You can have strings, which gives you lines of words, paragraphs of words, characters. And null, which is a special keyword denoting a null value, and null is also a primitive value. And there is a top-level property called undefined, which also has the value undefined. So yeah. Variables in JavaScript must start with a letter, an underscore, a dollar sign. Subsequent characters can also be digits, like x, var x would be 100, or let x be 100 is another way to do it. What you currently should use is let, because if you mix and match a lot of JavaScript, which you actually do in p5js, and you put in a var, then all of the other scripts that you're running, also the ones in the background, the libraries and everything, they all know your variable. So having a variable outside of your functions is kind of a bad thing, because it overrides all the other variables and can lead to unpredictable behavior. So use let and stay within your code. That would be great. The operators, we have already seen the plus operator. So you add stuff together, then you can compare stuff, like if A is bigger than B, then it returns either true or false, depending if it's bigger or not. There are logical operators like AND, OR, or XOR. That was my original example, XOR encoding in a lambda function, but I thought this was too complicated because nobody can do XOR in their head. I mean, if you can do, awesome. Then I cannot tell you anything new anyway. If you want to know more, find out more on W3 Schools. There is a lot of information about JavaScript. What you can also do is you can try it yourself, and that's actually quite fun. So if you say, oh my God, I really want to try this one out, then you can just open a new tab, hit F12, and you'll see the JavaScript developer console here. And this is actually connected to your interpreter. Let's see if I can make it bigger. And you can say something like, let x be 100. And there is no return value by that, so you get an undefined. And then I can say x, and x is obviously 100. And x plus 50 is obviously 150. So all those things we can also do is I can check the time with new date, and then we see it's 10:26, and my browser is set to German, obviously, with Mitteleuropäische Normalzeit. You can say something like let x be 1, 2, 3. Let's see if that works. Undefined. X is then an array. It gives you back an array and is printed here. And x1 is 2. As always, arrays start with 0, just because that is the case in all programming languages besides Lua. Yeah. So anyway, you can have a lot of fun with the console by hitting F12. Functions are blocks of code that perform particular tasks and are reused throughout your source code. So if you do something more than one time, consider using a function or putting inside a function. Function has a return value, like here, return p1 times p2, which would just multiply two values. And very important, you can branch code with the if statement. So of course, if something is smaller than 18, then do something else, do something other than that. Just to give you an idea that you've seen it for our examples later. And what we also need is loops. Loops go through stuff. So you run a code several times. And what you do often is using for loops. So you do, for instance, and take a look at the example down here. So I have to move away. This one, no, other direction. So for I is 0 until I is, as long as I is smaller than 5, I plus, and then it gives you something like text the number is plus I, and do I have the, no, I do not have the code in here, so I have to write it. I don't like to write the code, but anyway, I will try for let I be 0, I smaller 5, I plus, console.log I, and it logs 0 because it starts with 0. Then as 0 is smaller than 5, it adds 1 and runs it again, so it puts out 1. 1 is smaller than 5, and so on until it comes to 4. 4 is smaller than 5, so it adds 1, and then it looks at it and says, oh no, that's 5 is not smaller than 5, and stops there. So that's the whole idea of it. We have a for in loop, which is kind of practical if you have an array or dictionary and then you want to just iterate over the properties of an object. You have the for off loop, where you go through iterable objects like an array, and there's a while loop, which iterates as long as something is true. For instance, a game loop, while true, do, something like that. If you don't know about it, look it up or learn it along the way. As I said, my expertise level in JavaScript is mediocre at best. So for instance, I prepared an example yesterday for today, where many things went wrong, including that I mistook the for in loop with the for off loop. So yeah, you'll see what I mean there. I mean, the pros will see what I mean there. Everybody else will not notice, just like me. So, but what has this to do with p5js? That is the actual good question. I'll drink some chai latte in between. It's all in JavaScript. And you have the function setup, which is run at the beginning once, and then you have the function that is mostly your game loop. It's called draw, and it's run every frame. You can try it online at the p5js editor. So let's go there, p5js editor, put it here. And that's the function we have. So it makes a canvas of 400 and draws a background of a certain color. In this case, yeah, we can actually change the color maybe to white. It's an RGB code, and then you can basically select it. Let's make it this color. And if we change it to whatever bluish hue, then it paints it in the bluish hue, which is bluish on my side monitor and kind of violet on my main monitor, which again tells me that I have very cheap monitors, both of them. Okay, so that's the whole idea, and you change basically at every frame, and here you do always the same, so nothing happens. And instead of using the color code, we can also use an RPG red RGB value, that's it. And 255 would paint FF, which is hexadecimal for 3 times 255. If you just put in one number, it takes it 3 times, kind of. And 25 would then be near to black. 0 is actually black. And what we can do is we can say let col be 0, and then just draw col here. I don't use color because color is a keyword in p5js. And what we can do is we can add a ++ here, and then it would change the color from black to white with each frame. And maybe put in a 255 here so that it goes in circles. So that's the huge idea about p5js, and everything you can do in here runs every frame, and everything you put in here runs once. Say 320 by 240 would make the canvas smaller. Okay, I'll just stop it, otherwise it will run in the background, and I have a serious problem with that. No, not on this computer, but my old notebook was constantly dumped with different p5js files running at once because I didn't close or stop them, and then the whole lecture would go to waste, me waiting for my slides. So yeah, you can put the variables on top, like I did with the color value. Then whatever, you can have text in there. In the setup, we also did a 4x3 canvas, but in 320 by 240. Here we can have 640 by 480. In the setup function, we can also set up stuff. Like for instance, I want to have a lot of different points in the in my array, so I can basically go through the array and add random points in there. Yeah, and of course, what would I do with those points? I want to draw them, and the whole idea is then that there is a function called point, which would draw a point for us. It's the one here, and that's what p5js actually does for us. So that's the cool part. Let's see how this actually works by implementing it. And if you don't want to type, it's typically in the notes of my slides, just for myself too. And let's open an editor window here, close this one, and paste it here, and take a look at what it does. So again, we have a setup of 640 by 480. We create 10 times points, so we go 10 times through this specific loop. There's a for loop, creating 10 times points by creating always a new point with x and y, random number, And here we say what the points should look like. They should be yellow and have a stroke weight of 3. So basically the stroke of painting the points is 3 pixels white. And then let P of my points, here is the off, yeah, that works really great. Do not use in here. So P of points, we can just paint the point of PX and PY. Okay, let's do that. And here we have a black screen with 10 yellow points. And if we run it again, the points are somewhere different because, of course, they are assigned randomly. And of course, the fun part is we can make it 100 points. We can make it 1,000 points. We can make the points really big. We can make them really pink, and so on and so on. So whatever you want, you can basically change. Let's go back here to 3. And what you can also do is instead of point, you can use line. Line starts from somewhere and goes to somewhere. So there are XX and YY. And basically now every line goes from the point to 0, 0. Then it already looks different. So that's the whole idea. If you want to know more about what is, let's stop it. If you want to know more about what you can do, there's a really good reference on that. You can actually find it here in the help menu. So open the reference and then type in line, and you will get a few code examples and definitions. If you want to use your picture here, right mouse button and then just copy the image, and you can put it into your slides. So if you want to create dynamic images for your slides or for your Word documents or whatever, you can just copy it. So that's the easy part. That was harder with processing. So that's the benefit of using it. Yeah. What we can do now is, and you remember parallax scrolling, just to give you the idea how to make it more interesting. Using stroke weight, we can make some points bigger and some points smaller. So that's what we copied over. And so we have different layers. And actually, we need to add a layer to the point to tell us how far it is in the background, kind of. And that would then look like that. And let's go here, put it here, and take a look at the differences. So one difference is the layer part here. And we say we want to have a random number from 0 to 4. That's actually a random. I mean, you can use, we can actually switch it to an internal function of p5js. Here's the reference. It's a wonderful color for a reference page, I have to say. It's kind of shocking me every day I'm using it. But it's not my choice. And we can search for random. And obviously there are examples for randomness. And we can take a look at them. Oh, see, there's a function random, which goes from 0 to width, from 0 to height. So that takes away a lot of complexity. We don't have to use the floor function. We don't have to multiply math.random and so on. And there we can look up what works. So for instance, calling random -5 10.2 returns values from -5 but up to, but not including 10.2. So that is actually something we really like, and we can change it in our editor here into layer random 0 to 4, and that would come up with the same stuff. We are still missing this one, and then it should actually work. Yes. And what we also did was we changed the stroke width. The stroke weight, yeah, I always get this one wrong. The stroke weight, we changed the position from here to here because we are changing it with every point we're painting, yeah. And we're painting the layer, which is from 0 to 4, +1, because then it's from 1 to 5. We can say whatever from 5 to 9, and then we have bigger and smaller stars, but in a different way. We can have it more pronounced by multiplying it by 2. Yeah, this is a very intelligent editor, which basically takes away my agency of writing. And yeah, a lot of different stuff. Or 42, that might be interesting. No, not. Not interesting. Okay, leave it at 1, so we will have the basic difference. And yeah, so we can have a star field with, say, 1,000 stars. And we can have more layers, like 6. And yeah, make it, for instance, smaller by 0.66. And then we already have a nice image. Okay, let's go back. We can of course extend on that. So drawing shapes would also be an option. So instead of having these points, we can create random lines where we basically just put in these here. We have x1 and y1, x2 and y2, and the rest stays the same. We already tried the line thingy out. There's the code. I'll just run it so that you can see it. And yeah, for each time here, we have different lines. So not much of a great achievement. But what I actually wanted to show is, and you might know those fun stuff you did at the manual work in manual kids labor in school, in elementary school. So we did it, but it was a long time ago. So you had a wooden board, and then you would put in nails, and then you would have a thread like wool or some other stuff, and then you would use the thread to make lines between them, and if you follow the pattern of the lines, then it would make a nice curve based on lines or something like that. And that's actually what I wanted to do next. We can have, yeah, I could move it up here. We can animate those lines, and let's take a look at the source code and go through that. So basically, we would have the lines here, the classic lines. Although we remove the for, okay? So there is no loop. We just have one line which we push into that. Okay, we have 2 points that do something. So that's nice. And we're setting stroke and stroke weight. And the main thing is going on here. So start from here. What we do is we have one line in there. So what we do next is we add a line at the beginning of the array and move that somewhere. Okay, so we use these 2 points, like the new line would be the old line plus the point and the second point for the second thingy. So that's the movement vector. And then we put in the new line at the beginning and remove the last line if it's longer than 250 lines. Okay, and what we do up here, so this area, is we start with white, so we make it a white stroke, and then we'll go through all the different colors of gray and or shades of gray, and then we paint the latter ones darker, and then we have this shadow effect. Okay, let's take a look at it. It works out very well as long as it's not crossing. Okay. Why not letting go? Yeah. Thank you for the question. I'll come to that. So in this case, if they overlap each other, you see that the darker lines are drawn later and overpaint the white lines. If you recall the painter's algorithm from game engineering, that's why. So we have to turn it around. And it stays inside because I put in the collision here. I'll just reverse the vector. So that's the basic idea. So what we could do is we could start, for instance, with 0 and have something like stroke plus plus, which does not work, obviously, because we start painting the first line in black and then the last line with white. So it gives us a very different thing. So what we need to do is we have to reverse this for loop. So what we should do is we should let L be let L be 0, L smaller lines dot length. Lines, yes, should be lines, and I L plus plus, and maybe remove the auto refresh, then we would have less errors. Okay, and then line would be lines and yeah, L. So that would be the idea. Then we iterate the lines based on the number and not based on some iterable interface, and that still does not do it. L plus plus lines. It's called my lines. Yeah, of course. And that should do the same trick. So we just change the format of the for loop. And by changing the format of the for loop, we can actually change it the other way around. So we can say something like bigger than 0. Start with a higher value and count down. And the higher value would be something like that. And after some time, it's drawn from the back. As we start with one line, there is still something to consider, but it looks a little bit nicer. We had to reverse the loop here. Okay, now we can actually see what I meant with those threads. So if the lines are moving, here we are, then we have those nice curves in here, like here, yeah, here or here. By painting lines, you get curves. Yeah, and as soon as a line end approaches the end of the canvas, we just reverse the direction in this case, so that makes it bounce off. My internal code name for that is Quicks movement, because there was a game called Quicks where something like that would move around and you had to take away parts of the screen, so you can basically look it up. There are the not safe for work versions and there are the kids versions too. It was an old arcade game. Yeah, so that's the Quicks movement, as I said. And what we can also do is we can animate points. I thought it would be nice to have something like the layered starfield animation, because of course animation gives us the option to use the parallax as visual cue for giving the whole thing depth. And of course, my great idea was to do the Star Wars stuff. Was it in Star Wars? Yeah, basically at every science fiction movie where you could move through the stars. I mean, they would then turn to lines, for instance, in the Guardians of the Galaxy. But here, if you look closely, you see that the thicker points, the bigger stars, move faster away from the center than the than the smaller stars. And what I do here is I have a movement vector. So for each point, I add the movement vector, and the movement vector is an extension from the center to where is it? Turn on the pen. So the center is in here somewhere, And for each star, I calculate the vector to the star, and then I use this vector to move the star more away from the center. And depending on the layer, I multiply it with a layer dependent variable, and then the ones in the higher layers move faster away from the center. So it's still 2D, but it gives this impression. And here we are, didn't stop it. And we are at our star field simulation. And it looks much better than an animated GIF if you run it in here. I did not add new stars, so it thins out after some time, if going through a cloud. We can actually make all the stars move a little bit faster, which also gives a nice impression. And one would have to resample stars in there. But I just tried the naive approach. It doesn't look good because, of course, all the big ones are gone after some seconds, and then only the small ones remain, and then you have to resample the big ones mostly. So the distribution of putting in new stars was out of reach for the second lecture. We can go for that in advanced topics in computer graphics. Okay. What else can we do? Of course, we can use mouse and keyboard input. So that's also quite nice. Key gives us the last pressed key, and text prints text on the screen. So what it does here is we give it a text size. We give it a text size of 50. We say we want the text in this color, whatever this color is. A very light one, actually. RGB, blue. Yeah, maybe with a bluish hue. I don't know. Inferring is always hard. Guessing what color that is. That can be something that the people who are bored in the chat can do. What do you think would this color be? You can just put it in the chat if you want to go for a guess. And then I have to draw the background here. And the text key 3365 puts the key at this specific place. Okay, let's put it in there. So no guesses from the chat. You will see it right now. What is the hue? Oh, it's bluish stuff. Yeah, was a good guess. And then I have to click on the canvas once, and then I can actually type in. If I don't click on the canvas, if I lose the focus here, then it doesn't work. It's of course in here, and now it's in here. Okay, so the trick question would be here, what happens if I remove the background? And as we have a little bit of delay, I don't want to stretch it out too long. I'll just remove it, rerun it. And of course the background is not black anymore, that's one thing. And if I put in stuff, it works. But if I put in other stuff, you will see that it doesn't update the whole screen. So that is something in p5js, especially in 2D, with the background command, you erase the frame that was there before. If you don't want to erase the frame, then don't call the background. If you want to erase the frame, call it. Okay, and we can actually use keyboard input also by functions. So keyReleased would be called by p5js if somebody releases a key. So on key press, on key release, you might remember from game engineering again, the different key states. And then we can do an animation. And in this case, the animation here is a state machine. There is either the animation running or it's not running. And the animation size is 1. And if the animation is running, then something happens in there. And in this case, it just reduces the size. So animation size makes it smaller. And if the animation size is smaller than 0, animation is false. So it doesn't do the animation anymore. Okay, then it doesn't paint anything anymore. If a key is released, we start with new animation, and animation size is 1, so we start with 1. Okay, let's see what it looks like. It actually doesn't, I don't like it, but it's uncomplicated. So I press a key, G, for instance, and then it makes it smaller. So it appears to go into the back of the screen. Yeah, we can use different animation sizes, like whatever, 42 for instance. In this case I can do auto refresh. Oh, 42 is maybe too much. Maybe it's too much. Oh yes, it's definitely too much. Let's take 2 and 0.01 again and see what we do. Yeah, then it comes in big. And on release, you start with a new key. So that's the whole idea. Okay, so that was key input. You can all look it up on the reference. So key input. So there is key is down, key press, key release. There's a reference on that, and you can basically look it up, whatever you're interested. So if key is down, left arrow, and so on, then yeah, that's a state check in this case. Okay. What else? Mouse input, also very important. Mouse input, we'll need that later on. mouseX and mouseY contain the position, and mouse released would be a function for event handling. Then you can take a look at which button and so on and so on. So you can use the scroll wheel and everything. Okay, just a very simple script here, where we have a circle following the mouse. As you see, it's not snappy, and that's the whole idea. So it follows only part of it. So I take the distance, dx and dy, and I only move by frame 1/4 of the distance. So the steps will get smaller. That's the basic idea. Yeah, if you recall from game engineering, you can put in any function as a lerp function, but that's just an easy way to do it, to make it more juicy. Okay, so what else is there? You can save sketches in the cloud if you're logged in. You can use your GitHub account, for instance, which is what I do, and then it saves it. Yeah, you can give it a name and save it. We can do that with that one. Temporary script, and now it has a name, and we say save, and then you can basically find it in your collection, not collection, in your sketches. Temporary script, it's here with a date, and it's public. You can change it to private if you don't want others to see it. The same thing is possible if you save it in the cloud to download it. And actually, that is something, please, everybody listen now, very important, make a clip of that. If you submit your exercises, the first 7 exercises based on p5js, then use the download button, download what you programmed, and put this one on Moodle. Yeah, just this one, not in an extra folder, and so on, because I have an automated script that extracts the sketch files for me so that I can go through them. If I have to touch every file manually, the grading of the exercises takes a day. If I can use my script, it's much faster. And my script is really cool because it can detect if people work together. I can make a neighborhood graph and stuff like that. And if I have to extract each of the sketches manually and look at it, it's, yeah. So I automated a lot of stuff, so please stick to the download option. That would be awesome. If you do it locally, you can just mimic it by zipping the files in the folder. You can download it once, then you see what happens and do it like that, okay? What's the worst part is making a zip and then raring it and then tgz it, and no. Just simple zip does the trick. That's really awesome. Okay, what you can do for exporting media is you can use P5 capture. That's actually pretty cool. Or you can go to full screen mode and do a screen capture, or you can use a plugin. Option A, option B, option C. The plugin is basically the worst option. P5 capture is actually pretty cool. So what you can do is you can, I'll just do that here. Where's the web editor? Just do that here. So here you can edit all the sketch files, and while we mostly focus on the sketch.js, we can take a look at the index file here, and there you have different scripts. So typically the sound script we don't need, so it still works without the sound, but we can add the capture script in here, which is this line, and put it in here. And then we can capture it. There is a capture button. You can move it somewhere else, somewhere here. And then you can say, I want to record it. And then you record it. You press stop, and then you get a WebM file, which, hey, whatever. Let's try this one. Doesn't work. No, it does work, but somewhere else again. And once again. Yeah, and we have a video that actually shows what we did, so that's actually pretty cool. Would have needed that several times already. Okay, and now for the final part, the last 24 minutes of the lecture, we'll go into developing locally. For that, for the technical people, the short answer is you need to host your own web server. For the non-technical people, I'll just show you what I mean. So what you can take a look at is this local server documentation. But I've prepared a little bit about developing locally with Visual Studio Code, which has a plugin for that, and that's actually really convenient. Okay, let's take a look at that. We need a HTML file, which could look like that. And we need a sketch file, a simple sketch file like this one. So I can copy this one over, of course. Why didn't I put it in here? Much easier to do it like that. And here we are, Visual Studio Code. So the index file I also created already, and the sketch file, it's empty, so I'll just paste in whatever I have. And to give you, oh yeah, it needs some time because my magnetic drive is spinning down for saving energy. Most of the stuff is on the other drive, so but my project I keep there. Okay, so basically this is an easy thing with one canvas and a line in between. We have an index file. And what you do in Visual Studio Code, so VS Code for short, you install an extension called Live Server. Let's see, Live Server, that's deployed. It's very, very, very popular. As you see, it's 75 million times downloaded. And it allows you to right click here, say open with Live Server, and we'll just open your standard browser and connect it to a local web server. There's no need to worry about it. It's only open on your computer, so only your computer can access the web server. So that's really practical. When you're developing stuff, you can still leave this server open. This file open, and if something changes, it will actually change the output too. There is even a way to put in a browser here. but I forgot how actually, somewhere in here, I don't know, whatever, we can switch back. So if I say something like the line goes from 100 to 200, we can go here and the line looks different. If we wanted to have it from whatever, 0, then it goes from up there. Okay, I'm pretty sure there's also p5js plugin. Oh, we can actually take a look. Live p5js. Yeah. So there is one. I don't know if it helps anything, but the whole idea is actually that if you write JavaScript in here, then it would know that you're in p5js and it can help you figure out the right libraries and so on. Now it just does something really weird. I don't know what, but I cannot rely on the auto completion and suggestions and stuff like that. Okay, but we're set up locally. It basically works, and then we can change stuff. So what did I? Yeah, and what I wanted to do is use mouse input and some fun visual effect. So that's actually what p5js and processing are good for, these fun visual things. And let's see if I have actually put up some slides on that. I think, yes. Let's go for the next one. Yeah, that's the open with live server. As soon as you have the live server plugin installed, then it just works. And what I want to do is I want to create a raster of points where every 10 pixel there is a point, and then have the mouse pointer interact with the points to create a visual effect. Like in this case, kind of a lens effect. And so what we need to do first is create the raster. So let's take a look at that. And yeah, we're local. Let's see. I paste it here. Create a raster of points. Yeah, that's what we need here. And I could write it, but it would take too much time and it would definitely do strange stuff. Yeah, and these editors give you options like formatting your file that looks nice again. So what I just added is I have a raster, which I call data. And in there I have the points. So I create vectors. Create vector is a function from p5js, which allows for vector arithmetic. We'll come to that in Math 101, and it really helps. So each of those raster thingies has a position, and as we move it away, I don't want to change the position of the point because we have to snap it back when the mouse goes away. I just create an offset, and then I paint a point at a specific position plus the offset, okay? And of course the offset vector is 0, so there won't be anything. So I'll do something like, yeah, 220 is good. We need a stroke color, like, let's select one. Let's take dark red. Yes, that's a good one. And we can also go for a stroke weight. So something like 2. Okay, and obviously this should already be in our thingy here. Yeah, that's good. That's great. That actually works. And then we should make it a little bit bigger, of course, like 800 by 600. And here you can see that I use width and height, which actually allows me to change the raster size, and it would, regardless of what the size of the canvas is where I'm painting in, it would just do the trick. So that's the whole idea. I changed the size of the raster. Let's go back. Now it's bigger. Awesome. Okay, and now we have to do something with the mouse. So we add the mouse and interact with the points. Okay, so we can say something like, my mouse pointer is create vector on a mouse X and mouseY. And that's our mouse. And now for each point, we should decide if we move it or not. So we go through the points anyway, and that's the in and off. For point in data, it would be easier to say point off data. Then we can say something like p position and p offset. So you have to be extremely strict with what you're requesting from the programming language, otherwise it will just not work. So it didn't change anything, it made it a little bit more readable. Okay, and so for each of the points, and now here we have to move the point near to the mouse, and therefore we can use the offset, and what we need is actually a distance function. So let d be the distance between the mouse and the point, and that's where actually a reference comes in handy. We can take a look at, here is the reference. We can actually take a look at vector, p5 vector, and p5 vector gives us a lot of different functions. For instance, add, and so on and so on. And where are the methods? ToString, copy, add. Is it here? No, doesn't show. Yeah, rem, sub, mode, diff, mac, and so on. And what we can use is the dist function, because the dist function, now it shows here, the dist function gives us the distance between 2 points or 2 vectors, and we use dist between mouse and p, and then we say something like if d is smaller than, and we're on this canvas thingy, so say 50 pixels, then stroke weight 5, else stroke weight 2. And then we should be able to interact with the mouse. No, we're not. And that's the beauty of live programming. Stroke weight 5, stroke weight 2, dist mouse. Yes, that of course does not work. What we need is p5.vector dot dist. That also does not work, and what we can do is mouse dot dist p, and doesn't work either. Else if did I put in a typo somewhere? That is also often the case. Maybe remove the else, then we see what the if actually does. That's now called debugging. Nothing does nothing. If we remove it all the way, see if it still not works. Yeah, it still doesn't work. So there's some other thing going on which I don't like. Now it's back. Okay, something with the mouse vector, something with the distance. Yeah, I like live coding. Where are we? Here, the dist function. That's actually what I wanted. v1 dist v2. Should be a vector. Oh, yeah. The position. And here we are. Now it works. I mean, not because I actually removed most of the code, but now it, yeah. And we're here. So it interacts with the mouse. Yes. So know your JavaScript. Yeah, and actually a plugin would really help with that, because it would tell you, hey, guy, this is not a vector object. And also JavaScript is not really helpful because you can compare everything with everything. No, there's no type checking in there. So that's a very good approach on that. Okay, so we identified the points near it. So what we can actually do is we can go for those points and then move them a little bit away with the offset vector. So for p of data, we get the distance, we already had that. And then we reset the offset so that the offset is back to normal with set. And then we create this lens effect. And let's copy this one over. So we can actually adapt it. Distance. And yeah, that's the old one. That's good. Okay, so we still have to change the data p to p. Oh, do that automatically. Yes, that should work. So what we're doing is we are setting the offset to 0 for each of them, because we are changing it only for those that are smaller than the threshold. We need to have a threshold. Threshold be 50, something like that. And that would be our radius. And then the offset. And yeah, then change the offset depending on how far the point is away. And let's see how that works. Here are we. Yes. It does not work at all because I did not save the file, and it does not work at all. Okay. Let distance be, oh, of course, because this is called the mouse vector. And here we are. We have the lens effect, and we can actually make it a bigger lens, like 80, and we can have darker points, of course, and a bigger stroke weight, and then it's well viewable. Okay, so there's a lot of stuff you can do with p5js. These were just a few examples. So if you want to do more, of course, and I'll just show you this one more time. So I move the mouse and the lens sticks to the mouse. I could not stop yesterday because it was not snappy enough. So I created this one. And here, for instance, the mouse vector is lerped, so the mouse vector is moved towards the mouse, but it's not on the mouse. It doesn't snap to the mouse position. And the set is also changed by only part of it. So it's here. So the offset is only reduced by 1/8 and not set to 0. So it doesn't snap back, but it eases in. And here's also an ease in for the movement of the lens. So the lens focus is easing in, the points on the lens are easing in, and the points are easing back in their position when the whole thing is gone, and that gives you a very different experience and a very distorted lens. But of course it looks a little bit juicier. So that's the whole idea. We can make them bigger, of course, to have an even weirder experience on that. Yeah, and that's the whole idea, that you can go crazy with it, as you see with very small effects. So that was the juicy one. with a video of the juiciness. So just to give you an idea, because we're going to the first exercise, of course, I know there are many people in the course that cannot program or have not this deep knowledge about programming and are struggling already with fields and arrays and variable declarations and stuff like that. So please get together in groups, do it in groups. But at the end of the day, please also invest some time into making the source code your own, like changing stuff you really want to change. For instance, having the points in a different way, like small X's or small rectangles, or making them colorful, or adding juice, things like that. So give it your own touch, understand what you're doing, and then submit it. Please do not submit a group work because it's individual work. And for me, it's easier to see that's individual work if you add your individual touch to that. So that's the whole idea. The exercises are actually pretty small, so there's not much code to write, code to understand. So that's also a huge opportunity to add a few things, change the color, change the size, change the way it interacts, and so on and so on. You can be creative with that. Okay, so there is an introduction to p5js, which is pretty cool. And also there's a video coding the mouseY, which is a geometric structure that really looks nice. It's a lot of trigonometry in there, but not too bad. And you can watch the video. And if you watch the video, you have already a benefit because your exercise is to create these mouseY. You can follow the tutorial that I've given you in the slide before, create a p5js implementation of the mouseY and submit the zip file to Moodle. Deadline is in Moodle as well as in on the web page. Yeah, and if you have any questions, please start typing now because we're basically at the end. So I hope there was something in there for you. I know it's a little bit boring for those people who already know how to program, how to code, but everything you do, especially if it's outside the box you're normally operating in, gives you additional knowledge. And p5js is fun because it's so high level. And gives you great ideas what you can do with interactive graphics, which you can then use in, for instance, shader toy or FracCord, which is much harder to program. But if you already get an idea how to make a mouseY, then maybe you can do that in the shader programming part too, and get an idea what actually goes on there. Okay, next time we'll meet in person again at an unholy time of 8:15, and I'll put up the recording, of course, yeah, other than that, I will be available by mail, and thank you for listening.